Good morning, students. We stopped at electrical energy and electric potential, electric power. Electrical energy symbol is E, similar to electrical but came with the symbols. Energy symbol U also we take sometimes that is for the potential energies. Then consider the external resistance. Resistance capital R connected across the battery of potential difference T. Battery provides the potential difference only and makes the charges to pass. It won't provide the current of its own production. It won't be there. It only makes the electrons to travel from one end to other end. That travel from minus to plus electron motion. But the current direction take is opposite direction from high potential to low potential. So Ohm's law if you take now V is equals to IR. The function of potential difference is to move the charges across the external resistance. So we take the definition related to this. From the potential formula we have discussed the first topic is potential is nothing but equal to work by charge that is moved or work done to move the unit charge from one point to other point is called as the potential difference. Here R is resistance connected across the battery. It will be called as external resistance. Outside the battery cell is also called as a external resistance or simply taking resistance. I is current. V is potential difference. Potential difference across R, resistance R. So this is outside the cell, it's called external resistance because cell also has the resistance inside the material, inside of its materials called the internal resistance. I am discussing right now only external resistance. I just take a resistance R. So we are not going to discuss the internal resistance right now. Simply take it as a resistance, a resistor. Across R, the voltage is V. So we have the formula V is equal to IR. V equal to IR is Ohm's law. Next is work is done by the battery to move the charge Q across the resistance R in a closed circuit. Compulsory closed circuit is required for the charges to move. So W is work done by the batteries to move the charge Q through resistance R. In a closed circuit also to move the charge Q in charge Q through R in closed circuit. Charge moved is Q. Then potential difference becomes W also. Difference V is equals to W by Q. This is the basic definition. Delta V we have taken in the first topic, second topic. Potential difference taken as delta V or dV, but here we take it as a V only and cell always hold the potential difference only. And the 2 points from infinity to a single point means potential difference, that is V we take. Potential difference is dV or delta we take, but we take for the battery cells we always take it as a V only. When capacitors also we take V only. Voltage as a resistance also take it as V only. This is a potential difference. This is also dV or delta. If you want you can take also, but not also take. So work done is nothing but equal to V into Q. Therefore work done W is equals to Q into V. This is the relationship. So whatever work is done to move the charge across the potential difference, charge Q across the potential difference V is W equal to QV. The electric power is nothing but equal. And one more thing is energy we require, electrical energy. The energy spent by the battery, it is using the energy to move the electrons. So the energy spent by the battery is also equal to work only. Work itself is nothing but form of energy. Work is apparent. And electric power becomes is electric power. P is equals to 1 by time. 1 by 1 by time. This is W by What is T here? Time. Is the time T? T is the time taken by the charges to cross the resistance R. We can take, or in closed circuit also we can take. Where T is time taken by the charge Q. Time taken by the charge Q to move through the resistance R. To move through the resistance R is the time taken. Power equal to work by time. Therefore, power becomes what now is work is QV. Q into V by T. If you take dV delta, you know, here also we can take it as a dQ, we can take, or dt also we can take if you want. Okay, charge by time is nothing but current. P is equals to this I into V or V into I, where I equal to Q by T is current. Therefore, this is the expression for the power. Power is nothing but equal to voltage into current. Okay, electric power is nothing but equal to voltage into current. And you can, if you want expression for the power in terms of the resistance also, if you want, then you have to take the help of the Ohm's law. V is equals to IR. Like I said for I is equals to V by R. Like I said for V is equals to IR. Then you get a different expression for the power. Power has three expressions. This one expression is voltage into current, and other expression is but I. Substitution of R power equal to V into I. V is equals to IR. V equal to IR into I. That means power is equals to I square into R. Power is equal to I square into R. In terms of the current, if required, current and resistance required, no, I square R equals. What is actually effective in the electrical device is not the voltage, it is the current. Flow of electrons is required. So voltage is there, but the current is, charges are not moving, no use of it. So what is required is actually the electrons collision is required with the atoms to produce the heat. Okay, or energy conversion into heat energy or other forms of energy, the electric bulbs and energy devices. So what is important for us is I is important. But I is not given, you have to get the V and R, then you can use the help of V is equals to R to get the electric expressions. Then now we can also take this I is equals to V by R. So power is nothing also, or you can also write this one. This is one equation, first equation. This from this only we are taking the substitutions. This is second equation. So this is second work. This is third. This is fourth equation. But the power equations one we need to remember. Two. Next is R. Power is equals to V into I. V into I is equals to V by R. V by R. So power can also written as V square by R. This is equation number 1. So this equation, this equation, this equation. Three equations are important, you will remember for the power. But if you don't remember all the three, don't bother. One formula you remember means other you can convert with the help of V equal to IR. These are the expressions for the powers. If you require energy is nothing but equal to power equal to work by time. So work is nothing but equal to power into time. Electric energy. E. Electrical energy is nothing but equal to work. Work by the battery is nothing but equal to energy expended or spent by the battery cell. Work done by battery is equals to, that is W, is equals to electric energy, which is nothing but equal to electrical energy P. So what is the work done? Already we have taken the power equal to work by time. So work is equals to, therefore work on energy, which is nothing but electrical energy, is equals to power into time. Electrical energy is nothing but equal to power into time. That is P into T is nothing but equal to electrical energy. And power already we have got this relationship, three equations. Therefore, we can also write this as R. Energy is equals to power into time. Power is VI we get later. So VIT R is equals to I square R into T. R is also equal to V square by R into T. Any of these formulas can be taken for the energies. Remember these are the equations for the problems of the this. What is the energy spent by the battery or used by the battery? As energy spent, and the battery becomes weak and weak. Battery cell should not get heated up. Like using the cells, it should not be heated up much. Okay. And should not cool too low also. Electrolyte will not function properly. The resistance of the electrolyte is important. And in this I square RT is called as joule heating. Joule heating or joule heat. Work converted into energy. Joule what he has done is Joule gave the relationship between the work and energy relation. W equal to JQ. Work is proportional to heat energy. Heat is produced by the doing work only. That is the relation given by the joule. And if you rub the hands without any fire etc., rubbing the hands become warm. Why is it becoming warm? You are doing the work by friction. That work doing friction, work is converted to heat energy. With the heat without getting any other heat sources, you are able to get the heat without any rise in temperature. Direct temperature rises, heat is produced by doing the work. Work and energy relation are given by the joule. And here by passing the current through the resistance R, heat is produced. But here in time T important here. For power relation we don't take the T, careful with that. T won't come here. For work only energy only T comes. So in 1 hour how much heat is produced in the resistance? In 2 hours how much it is produced? Like the time is required here, we have the heat energy produced. It's called joule heating. Joule power is nothing but equal to I square R, not V square by R. All the three forms are there. But power loss, heat produced, talking no, we have to use the term I square R term. So that means proportional to R. More resistance, more power. More current also, I square is coming here, not I. So I square means I is double means power loss also, power heat power also increases. This electrical heaters etc. working based on this relationship. How much is produced? The resistance, the wire important, electrical wires, micro wire is used for that purpose. How much resistance is there? R. How much current we are passing is I. Voltage may be there, but we have to calculate I because current required. How much is passing through the resistance will be required. So I square R is important for us, and this is called as a joule power loss or joule power heating. This is not the joule heating, just heat only. This is the power. That relation I will mention. In time T seconds. Power loss or power, electric power converted to heat. Converted to heat. Converted to joule heat. Joule heat. Electric power converted to joule heat is equal to I square related to this current only. Okay. Converted to heat in the resistance space. In the resistance R related. And the power supply is taken from the power stations, electric power stations. Like thermal power station is at Ranchur in Karnataka. Nuclear power station is at Kaiga near Dandeli. Okay, this long distance electric power need to be connected to the houses. So lines are coming, electric wires connected from the electric wires are connected from the power station to the houses. Houses are located some hundreds of kilometer distances. So from the power station, here is a power station located. Okay, this is a power station located. In between you find the poles and then electrical wires are taken over this. near the houses, even houses are located. Long distance they have to travel. This wire will provide the resistance for us. Okay, to reduce the resistance, what we can do is you have to use a thick wires. One thing, thick wires we have to prefer. But even if thick wires are taken, also resistance length is very large. R is equals to O into L by A. Copper and silver we cannot use costly ones. Second thing is copper, also not the costly next costly ones. Next thing we have to prefer is aluminum. Aluminum is preferred for this electrical wire connections for long distances. So, but more length, more resistance, more resistance, more resistance, more power loss. Okay, power is nothing but equal to voltage into current. Power equal to V into I. Okay, there is a device called the transformers. Transformer contains a coils. With the help of the transformer, we can increase the voltage, we can decrease the voltage also. But power remains constant. Ideally, there is no power losses means power should be supposed to be same in the transformers. So transformers contains the coils. At the station, this is a power station. At the power station, step up transformer is used, which means voltage increases. Step up transformer means voltage increases. The wire, the resistance of the wires in cables is a RC. Okay, connecting wires for symbol is given in textbook are given as a cable wires. This wire cables resistance is a RC, total wire resistance. Okay, more resistance means what? More power loss will be there. So, in a given current. So, what you have to do is you cannot change the resistance because length is compulsory fixed. Now, we have to change only the current. But current cannot be reduced because same current power need to be used. So, this instead of current, large current, low current is passed, not high current. Low current is passed. For the purpose, what is done is step up transformer is used. This step up transformer increases the voltage near the power sources where the station is there. Here 230 volts if required for the house domestic purpose, 230 volts AC current is. AC means alternately plus minus will be changing. For the battery always fixed direction is there, linear direction current, one direction only. Plus minus fixed terminals. For AC current not like that. Alternately it is a plus minus. AC current will be like this. In India we have the AC current plus minus. Current electron try to go this side. Sorry, this side and current opposite direction. Then suddenly it changes to minus and plus. That means electron instead of going again turn backwards. Again it turns, changes polarity. The result is electrons don't go anywhere. They just execute a simple harmonic motion. When it is minus, trying to go like this. When it is again plus, trying to go like this. So result is electrons simply execute everywhere through the conductor. Electrons execute only as a jump, simple harmonic motion. They try to go again come back. Again go back like this. They keep on oscillating. That is AC, alternating current. Alternately polarities will change. At what rate it changes? 50 cycles per second called 50 Hz. In India, the frequency of AC is 50 cycles per second, 50 Hz. This is AC cycle plus minus. This is one cycle. So 50 times one side is plus, other side is minus, and vice versa changes. So current is positive. The effect is same as the positive. No, they produce the heat in the resistance. Here also everywhere electrons are there. They oscillate. Here also they oscillate and produce the heat. Condition is similar, but about AC we have a separate topic. The thing is here, what I want to say is with the help of AC we can convert the increase the voltage easily with the help of the transformers. So the step up transformer is called step up. Means voltage increase generally in our place what they is 230 kilovolts, 230,000 volts. This is called high tension wires. This is called as a step up. Voltage increases, step up transformer, high voltage is produced. So inside this wires the voltage increases. Whenever the voltage increases, power should be same. Whenever the V increases means current decrease. So this product remains same. So low current is passed, high voltage. They are called HT wires, high tension wires. You have the high tension wires outside this college. Those at large height they are kept because at high voltages even air also can start conducting easily when the humidity is there. If you stand at some distance of 1 meter also you get the electrical shock, sparking jump from the wires under. To avoid it, more height, more distance is maintained from these wires compared to the domestic wires. In the houses is only 230 volts. That's not much dangerous than that of the 230,000 volts. Okay, and more than 40 volts. If the voltage is more than 40 volts, you will get the electrical shock. So if the current is large enough. Current is also important for us. Voltage is also important. Okay, the electrical shocks are for the working purposes. So here 230 volt, 1000 volts will be taken. 230,000, 230 kilovolts. 230 kilovolts, low high voltage is passed here. At domestic we cannot use this 230 volts. High voltage, low current no use. We require high current also, high voltage also. 230 volts, but specific current is required. Some 1 ampere, 2 ampere current like that required. So here current is very less. Means what? Electrons are very few electrons are able to travel. Current is less means what? Few electrons. But voltage is high means more pushing is there. Electrons not going. But here what is done is step down transformer is union of this. Step down transformer reverse of it. Number of turns will be reduced. It's called as a step down. From 230 kilovolts, from this 230 kilovolts, they reduce to 230 volts. So we can use a voltage. Again, voltage reduce means current increases. So combine at the same value, we can use it as this. So what we are doing in this process is here in the wires we are using high voltage at low current. The result, power loss in electrical wire connections. That is important for the problems and complicated ones. Loss in connecting electric wires and take it as a cable, not dimension. Cable is power loss, is power PC. This is a loss or P loss we can take. Is nothing but equal to I square into R cables. R cables. I square into R cables. So more resistance because of more length, more resistance will be there. Resistance of wires or cable is RC, and this RC is equals to rho into L by A. More length, due to the more length, we cannot increase the area of cross section by large amount. They are already thick, but we cannot increase to very thickness. Okay, because weight also increases and quantity required is more of the material, and because already the weight is high and more weight means poles also cannot withstand their own weight also bend the wire downwards. So here L is length of wires. So large lengths R is RC is large for large distances. Therefore, what is done is voltage is reduced, increased, when current is reduced. Or actual power is actual power supplied is P is equals to V into I, and I is equals to P by V. I equal to P by V. This we have to use here. Therefore, power loss. Power loss, P loss is equals to I square, means P by V square into R cable or R wire we can take, which is nothing but equal to P square by V square into R. Here initial power is constant, so what we can change is only the voltage. Therefore, this P loss is inversely proportional to V square. Length of the depending on the length, no, R is also constant for given R cable, power. For given R cable, that power constant will be is also here on the voltage. This is constant. P is constant. That is the initial power produced by the at the power stations. This is constant. Now what we take is I substitute here into P square by. So more voltage, less power plus. Therefore, if V increase, then power loss decrease. They will ask you the question, why high voltage is preferred to high current, or why the voltage is very high in the high tension wires? Why? Because when the voltage is high, power loss is less. Therefore, for large distance of wire connections, electric wire connections, high voltage is preferred, high voltage, low current is preferred. This point is important even for the complex also. In the houses, electric devices are currently parallel, they have the same voltages. And what is the SI unit of, what is the practical unit? Practical unit of electrical energy. In the houses, you get the electric bills. That electric bill unit is called as the electrical unit of energy. What, how much energy you are consuming, that only they will give you as the electrical energy consumption. Unit of practical unit of electrical energy. Practical unit of electric energy is practical unit of electric energy is kilowatt hour. Kilowatt hour. Practical unit of electric energy is kilowatt hours. Kilowatt symbol in means just H or HR is there. KWH also noted, capital. This R if you small power, remaining this H is small, hour it indicates. Sometimes written of course, like this also written, only H is written. Like this also written. Kilowatt hours. Kilo means what are 1000 watts. Electrical energy. Practical number electrical energy is kilowatt hours. And 1 kilowatt hour equal to how much? 1 kilowatt hour is equals to, kilo means 10,000, means 10 to the power of 3 watt hours. 1 hour converted into seconds. So this is 10 to the power of 3 watt. This is watt into 1 hour. 1 hour is nothing but equal to 60 into 60 seconds. You get is 36 into 10 to the power of 5 watt seconds. Watt seconds means seconds. Power into time. Power into time is nothing but equal to work unit, energy unit. So W into 1 second is power is watt means you get is joules. So it is nothing but equal to 3.6 into 10 to the power of 6 joules. Or you can remember up to 36 also you want to know 36 10 to the power of 5 joules is a practical. And how electric devices are connected in the office? Electric devices, that is, are in parallel in houses. Devices in house are in parallel to the voltage. That means they are the same voltage. These are electric devices means fans, bulbs, okay, etc. All these electrical appliances they are called. Electrical appliances, electrical devices are connected in parallel, so therefore B is the same. And electrical energy, how much consumed based on this, we will calculate again. Unit, 1 unit they will mention. This is nothing but equal to 1 unit. 1 kilowatt hour itself is 1 unit. 1 kilowatt hour means 1 electrical unit. So 1 unit equal to how much rate?